Now, there's a funny story in the discovery of gallium. When Lecoq first isolated gallium, he had an impure sample. He didn't know the sample was impure, and the density was lower than 5.9. So he wrote to Mendeleev and said, "Dear Professor Mendeleev, I think I have found Eka aluminium. Everything about it is like you said, but the density is somewhat lower than what you said." And within days, he gets a reply from Mendeleev saying, "Dear Mr. Lecoq, your experiment is wrong. You please go and do the experiment again. Yours sincerely, Mendeleev." World War One started here. World War Two started here. The Cold War was here. Today, the Ukraine thing is here. Everything is. Whenever the two utterly different civilizations start clashing with each other, that's when you're going to see conflict and bloodshed. See, this morning, dear friends, on the last day of 2022, I want to talk to you about the periodic table of chemical elements, which was laid forth by the great Russian chemist Dmitry Mendeleev. And the title, as such, is of great interest to chemistry people. The subtitle, however, I hope is of interest to a great many others, because the periodic table is one of the greatest triumphs in modern science that illustrates what we call the civilizational divide. Two totally different ways of thinking about science and thinking about life itself in two different parts of the vast Eurasian landmass. My plan in this talk, which will last roughly 1 hour, little less than that, I hope, would be to first tell you a little bit about these two different ways of thinking, and then go into using this as an introduction, talk about the periodic table itself, and show why Mendeleev was successful, whereas his other competitors were not. And then I will end up again coming to a modern context where the civilizational divide in different parts of Eurasia is now having a fundamental effect on geopolitics, geostrategies, and in fact, even the future of the world itself. So this is a big theme, and I'm using a chemistry example because chemistry is my favorite subject. And so the example is from chemistry. But I hope that I will be able to say something of much more general importance. Now, we're talking about the chemical elements, and humankind first started thinking about elements, atoms, the smallest indivisible things that constitutes matter, again in two different parts of the Eurasian subcontinent. This is Thales from ancient Greece, maybe 2nd or 3rd century BC. And he first talked about the 5 elements: earth, water, fire, air, ether, and said that these were the basic elements, and all matter could be considered as a mixture of these things, some kind of a mixture. Now, on the other side of the world, we in India were also thinking about similar ideas. I mean, Lord Shiva is worshipped in the form of the Panchabhutas, Prithvi, Apas, Tejas, Vayu, Akasha, in 5 grand temples in the southern part of our country. I show the picture of Tiruvannamalai, where Shiva is worshipped in the form of fire, Agni. Agni Lingam it is called. But our story doesn't end with the Panchabhutas. Five primordial elements might be these things, but our ancients defined five more subtle elements that constitute these Panchabhutas, and these are called the Pancha Tanmatras. And they are represent the sense elements. Notice also here in Panchabhuta, I am gone in the reverse order from the Greeks. I start with ether, then I go to air, then I go to fire, then I go to water, and finally I come to earth. The Greeks started with earth and they ended up with ether. In fact, for many centuries, they felt they could not understand that ether. We started with ether. Now, why did we do that? See, because these Pancha Tanmatras, as I said, are the sense elements: sound, touch, form, taste, smell. So your Akasha, which is ether, you can hear it. Vayu, which is the wind, air, you can hear and feel. Agni, fire, you can hear, feel, and see. Apas, water, you can hear, feel, see, and taste. And finally, Prithvi, you can hear, feel, see, taste, and smell. So for us, Akasha is the first. Prithvi is the last. So you see, the Western way of thinking and our way of thinking, completely opposite. This is the first thing I want you to understand. We thought about the same things, matter. But we're thinking about it in entirely opposite ways. Now, let me give you one more example. Now, here are two pictures of two cities at extremities of the Eurasian supercontinent. The one on the left-hand side is a place called Königsberg in Germany. Both these pictures, incidentally, were taken about 100 years ago. I chose the pictures so that they would represent things that were taken around the same time. So Königsberg, literally in German, means King's Mountain. König means king, and Berg means mountain. Now I want you to see this. So that means there must have been many kings in this place, in this Königsberg place. So you can see the picture, you can see the big church or town hall or whatever it is. And so many kings, it's about 1,000-year-old city. So from its very name, you can make out that many kings came, many kings went. Now today, if you go there, suppose you want to travel to Königsberg and you check up, book my flight, and then you enter Königsberg, it will not show any result. Because there is no place called Königsberg today. It has vanished. This church is gone, these roads are gone, those trams are gone, everything is gone. There are no more Germans living in Königsberg. So there is nothing of this picture on the left-hand side left today. Now, what happened to this place was, in the last fiery days of World War II, this place was completely destroyed by the Russians. And in fact, the name of the place itself was eliminated. It is now a part of Russia, and it is called Kaliningrad, and it has nothing to do with this Königsberg place. So you can see in that old Greek way of thinking, things can vanish completely. What was there and what was standing for 1,000 years can vanish. Now let's go to the picture on the right-hand side. Now this place, which we all know, is not 1,000 years. It may be 5,000 years also. It may be older than that also. We don't get into any arguments on how old this place is. It is also a place of kings. Many kings came, many kings went. These kings came, they built some things, they destroyed other things. They still continue to destroy and make in this place that we call Kashi. But then there is a difference between Kashi and Königsberg. there is one super king here in Kashi. And I think we know the name of that super king. He is called Vishwanatha. So this king, we don't know when he came, but we all know that he will never go away from this place. So you see these two opposite ways of thinking, that Western way of thinking and the Eastern way of thinking, they can result in completely different consequences. Things in Kashi may seem to vanish, but they never really vanish. Things in Königsberg, once they go, they go. So you must remember that we, when I say we, I mean Indians, Bharatiyas, we think fundamentally different from people in the West. Make no mistake about it. I mean, the fate of these two cities itself should emphasize this to you. Now, having said this, let us go to this chemistry example of the periodic table. And I'm going to talk about the story before Mendeleev, then Mendeleev himself, the fellow on the left-hand side of the screen, and what happened after Mendeleev. And now we come to the fellow on the right-hand side. Notice he has also got a big beard. He looks like Mendeleev, in fact. I'm sure most of you don't know who he is. I'm going to tell you his name a little later in the talk and why he's very important for the Mendeleev story. Because now we are talking about Eurasia as a civilization, as different from the Western civilization of Königsberg. Incidentally, I've mentioned Königsberg. It's not just any odd place that I have mentioned. And it is not because the name starts with K, because Kashi starts with K, nothing like that. Königsberg happens to be the hometown of the famous German philosopher Immanuel Kant, who in many ways represents the culmination and the high point of Western philosophical thought. So Kant's place was Königsberg, and that's why I mentioned that particular name. And if you are wondering why I wanted to pick this rather obscure thing, which is actually not even known today. Now let's go to this periodic table story. Now you see, there are things known as the chemical elements. From the beginning, some of these have been known. And then in the run-up to Mendeleev, we have some important chemists called Lavoisier, Boyle, Dalton, Cannizzaro, whom I'm going to mention very briefly. But this is actually the before Mendeleev part of the story. Now, some of these chemical elements, which are chemical elements today in the periodic table, have been known from antiquity. And these 12 are actually the elements we know from antiquity. Copper is the oldest actually. But all of them are pretty old. And what distinguishes these chemical elements is that they are either obtained in nature in the pure state, or they are very easy to extract from the ores. Very, very easy to extract. So with a very little kind of a manipulation, you can get and identify these elements. So these are elements from antiquity. Basically, it was known that elements were chemical substances that could not be subdivided further. That is the really definition of a chemical element. As opposed to things which were occurring in the form of oxides, sulfides, and so on. People knew they were not elements. Now, we too knew about this. If you go back to the Yajurveda, there's a beautiful statement there, which says, Hiranyam cha me, Ayas cha me, Shisham cha me, Trapus cha me, Shamam cha me, Loham cha me. Hiranya is obviously gold. Ayas is silver, Shisham lead, Trapu tin, Shamam probably iron. There is some doubt whether it's iron or bronze. And Loham is copper. So we knew about these things. So it's not that these elements from antiquity were not known here. In fact, there are some interesting stories about the discovery of these elements in India. Now, coming back to the West, phosphorus was an element that was discovered fairly early before people really clearly knew what a chemical element was. They had some vague ideas, but it was not still properly defined. But phosphorus is important because it was discovered very early in the pure form. This is Lavoisier, whom I spoke about. Probably one of the greatest chemists who has ever lived, if not the very greatest, because he is the chemist who discovered an oxygen, which is the most important element in the periodic table. Then we come to John Dalton, who said that elements are made of extremely small particles called atoms. Now you see, you go back to Thales and you go back to the Panchabhutas and all that. So humankind has always realized that there are some small indivisible constituents of matter. So whether they're called atoms, elements, something like that, it's not exactly what you call them, but the fact that people realized that there were some very small things that could not be subdivided further. Atoms cannot be subdivided, created, or destroyed. And then we talk about chemical compounds and stuff like that. This is well known to chemists, and there is no need for non-chemists to know about all these things. So the main idea is that humankind realized that there were very small things called atoms and elements. Now we come to the problem of the periodic table itself. Around 1860, there was an Italian chemist called Cannizzaro who started assigning weights to these chemical elements. And then he started with hydrogen, which is the lightest element. And using some very careful experiments that he was doing on heating these elements, etc., he was able to assign, this is all written in Italian, but you can see here he says the hydrogen atom is 1, and chlorine is 71, he says. Bromine, he says, is 80. And then bromine is also 160. He says atom of bromine is 80 and molecule of bromine is 160, which is quite correct because a molecule of bromine contains 2 atoms of bromine, and so on and so on. So he was able to give a system of atomic weights. This is the principle of this atomic weight thing that Cannizzaro established, 1860. Then chemists being chemists, scientists being scientists, we are all very curious. Then there was a chap called Doberreiner in Germany, and he started seeing some resemblance between similar elements. For example, lithium, sodium, and potassium have similar properties. Then he found that the atomic weight of sodium, as given by Cannizzaro, is the arithmetic mean of the atomic weight of lithium and potassium. And similarly, you have another triad called calcium, strontium, barium, and then chlorine, bromine, iodine. So all this looks too much to be a coincidence. What is the meaning of all these patterns that seem to be emerging from these chemical elements? So then there was another guy in England called Newlands. From the triad, he went to 7. And like the musical octave, Sarigama Padani, so he said that you have octaves in all systems of music, by the way, not just Indian music. So he said that the 8th element is a repeat of the first. So 1, 2, beryllium is 3, boron is 4, carbon is 5, nitrogen is 6, oxygen is 7. By the time you come back to 8, he said it looks like 1. 9 looks like 2, magnesium looks like beryllium, aluminum looks like boron. He says it's just like the musical notes. These chemical elements seem to follow some pattern. Now, when people start saying things like this, relating some chemistry property to some musical notes, obviously many people are not going to take it very seriously. It was considered, these ideas were considered to be all fanciful. But somehow with the law of triads and the law of octaves, it was too much to be a coincidence, So there was further doubt, further questioning in the minds of chemists as to what exactly was going on with these chemical elements. Now, coming down further, the biggest breakthrough in the pre-Mendeleev era was done by this German chemist again, Lothar Meyer. Now, he was able to make out a pattern in a much larger group of elements. Now, what he found was that if he takes atomic mass on the x-axis, that is the weight, and the atomic volume on the y-axis. So basically what you're doing is it's a measure of density. And things in the bottom of this graph, like all these metals, vanadium, chromium, manganese, iron, cobalt, these are all the heavy elements. So for the volume, they have a much higher mass. And these would be the lightest elements, helium, krypton, and so on, the gases. So now Lothar Meyer started finding in a much larger group of elements some sort of a pattern. Now we're beginning to see a pattern that is not invoking any fanciful things like a law of octaves and musical notes and stuff like that. This is all real scientific method of analysis. Now it is clear to everybody that these chemical elements that were known at that time, there was some system in the way the properties were related to the structure. This was very, very important. Then once this is known that there is some relation of property and structure, then the next question is, what is this relationship? And this is where the hero of the day, Mendeleev, comes into the picture. Now, he was a wild guy, Mendeleev. He probably had Siberian origins, and he was an extremely wealthy person. From his family, he inherited vast tracts of land on which he used to run huge dairy farms. And in addition to that, he was very, very crazy about chemistry. He was a professor at a very young age. At the age of 26, he wrote a textbook of organic chemistry, which became a bestseller. In fact, the periodic table is traditionally not connected with organic chemistry, but before he did all this, at the age of 26, he wrote a bestseller textbook in organic chemistry. So he was clearly very interested in chemistry, and people say that there's a description of him that he looked like a wild Siberian. And one person actually describes him as he actually looked like a shaman. You know, these holy men who go about, and apparently most of the time when he was thinking, he will catch his long beard and go on pulling it, much to the annoyance of people around him. So he was really a wild guy, and he was totally obsessed with chemistry, and this periodic table then became a fixation with him. Now, what did he say and what did he do? And now we come into the civilizational divide. These are his original notes. What he did was, he took those atomic weights of Cannizzaro, and then he started, well, these are the chemical elements. This is hydrogen, this is lithium over here, boron, beryllium, boron, carbon, nitrogen, oxygen, etc. In his own handwriting, scratched out here and there. So he started arranging these elements according to the atomic weights, known atomic weights of that time. There are certain very important points about this list which need to be explained, which I can't do in this handwritten thing. So I'm going to show you the printed version here in the next page. And now here you see his plan of these elements. So hydrogen is 1, then beryllium was 9, then boron 11, carbon 12, nitrogen 14, 16, 19, etc., etc. He puts all these things. Now, if you notice, there is some very peculiar things he has done here. Two very peculiar things. The first is, I want to show you this two elements, tellurium and iodine. This whole list is organized in order of increasing atomic weights. But if you see tellurium, this is 128, which is a higher number than iodine 127. And so he has reversed the order of tellurium and iodine. And actually on tellurium, he has put a question mark. So he knew what he was doing. He knew he was reversing these order of tellurium and iodine. Similarly, he would take this bismuth. He puts 210 and puts a question mark. He has put a 197 question mark on gold. So he had some doubts in his head. But he didn't seem to have any doubts on where he was placing these elements in this list. The second peculiar thing about this is even more peculiar than the first one, is that there are some atomic weights that are written like 45, 68 and 70, where there are no elements also. So what's going on here? There is some atomic weights are there and there is no element here. What exactly was Mendeleev trying to do? There's another question mark for 180. All sorts of question marks. These question marks are the key to Mendeleev's success. And it represents a way of thinking which would have been unknown in Königsberg, but quite familiar to everybody in Kashi. And that is why I showed those two pictures of Königsberg and Kashi in the beginning. These question marks. What did Mendeleev do? You take this. This is aluminium. Okay, this is written in Russian, but I'm telling you what it is. This is aluminium. This is gallium. This is scandium in the modern periodic table. At the time of Mendeleev, gallium was not known. It is one of those question marks. Aluminium, of course, was known very well. Mendeleev put this question mark because he wanted something in the same row as aluminium. Aluminium 27, question mark equals 68. There was no element known between zinc and arsenic in those days. Lothar Meyer would have taken arsenic and put it up here because that was the next one after zinc. And that's when he would have landed in a mess because the properties of arsenic are nothing like the properties of aluminium. Arsenic is more like phosphorus. So Mendeleev put it there. That's why he was able to put arsenic very confidently next to phosphorus. He said what Mendeleev said, which would not have been a scientific thing using Western thinking, is he said there must be some element that is not known to us that is very much like aluminium and has an atomic weight of 68. This he called Eka aluminium. Mendeleev, by the way, was a great fan of Sanskrit. He belonged to a group of North Europeans who were very fascinated with Sanskrit in the middle 19th century. So that's why he said there is an element like aluminium, which I am going to call Eka aluminium. He even gave it a symbol EA. He said its atomic weight will be about 68. Remember, he said question mark equals 68. He went further. He said the density will be this much. The melting point will be low, he says. The valency would be 3, he says. He talked about the oxide. He talked about the density of the oxide. It's almost like he knew about this whole thing without knowing without it being ever found. He knew everything about gallium before anybody found gallium. Now, when he made this prediction, when he announced his periodic table, when he announced the periodic table and said there must be something like this, immediately the Western scientists, the Germans and all of that time, they reacted in horror. They said, what's going on? What is this guy talking? Without data, he is proposing a theory. A few years later, a chemist called Lecoq in France actually discovered gallium. And these are the final properties of gallium, which, as you can see, are very close to what Mendeleev had predicted earlier. The prediction came before the experiment. Very important. Now, there's a funny story in the discovery of gallium. When Lecoq first isolated gallium, he had an impure sample. He didn't know the sample was impure, and the density was lower than 5.9. So he wrote to Mendeleev and said, "Dear Professor Mendeleev, I think I have found Eka aluminium. Everything about it is like you said, but the density is somewhat lower than what you said." And within days, he gets a reply from Mendeleev saying, "Dear Mr. Lecoq, your experiment is wrong. You please go and do the experiment again. Yours sincerely, Mendeleev." Now imagine somebody saying something like this. Somebody reports an experiment and then you tell him your experiment is wrong. So sure was Mendeleev of his theory that he said the experiment must be wrong because he knew his theory was right. See, this is again like opposite. They ended with ether, we started with ether. Same thing. This man is starting with a certain feeling about the periodic table. He knows that periodic table of his is correct. So he says anything, any experimental fact that doesn't fit into this periodic table, that experiment itself has to be wrong. You see, again, this reverse thinking. This Königsberg, all these kings going away and the place being destroyed, and Kashi with that super king, Vishwanath, sitting there going on forever. You see, opposite. There is no meeting. Kipling said east is east and west is west. Never was a truer word said. The whole question which I am now going to come to is that Mendeleev was more part of the east than to the west. That is what I'm coming to. This is the point I'm trying to make. When he said that your experiment is wrong, then that fellow went and did the experiment, and Mendeleev was right. Then he came back and said, "Sorry, my experiment was India. I was having an impure sample, and this is the density of gallium which fits in with your prediction perfectly." The end of the story. So it was not just gallium and Eka aluminium. Many predictions he made like this, which have all turned out to be correct. Gallium, scandium, germanium, technetium. None of these things were known at the time of Mendeleev. In fact, he became so ambitious that he even went to 3 and all that. Because in the subsequent rows of the periodic table, Eka was in the row below aluminium, then in the row below that was Dvi, and the row below that was 3. So he was quite confident. All these elements, by the way, have been found. And they all seem to have the properties. Rhenium looks like manganese. Polonium has properties like tellurium. No problem. So the gentleman was completely correct. The full list of Mendeleev's prediction with their Sanskrit names as given by Mendeleev. And this is what we are now coming to. How did Mendeleev get this picture? It is using something called intuitive knowledge. There are 2 types of knowledge: intellectual knowledge and intuitive knowledge. Intellectual knowledge is what is practiced by the Westerners, the Kantian philosophy of things. You have a lot of data which is obtained very accurately. You take all the data and then you take that information and develop it into knowledge using an analysis of that data. Now, intuitive knowledge that Mendeleev used is totally different. Now, look at this picture on the right-hand side, this colored picture. You look at it. The proof of Pythagoras theorem comes out immediately. You don't have to do all those complicated proofs, drawing those dotted lines or going to similar triangles and all those things we learned in school. Here is the proof of Pythagoras theorem, which comes from Vedic mathematics. It just says in the treatise, it says, "See and behold." That's all. You see it, and then the result is there. It is certainty. And one of the finest examples of what intuitive knowledge is all about is written in Radhakrishnan's book, An Idealist View of Life. I think any educated person, if he has not read this book, it's a small book, you should read it. He says the characteristic of intuitive knowledge is certainty rather than communicability, which characterizes intellectual knowledge. Communicability means I saw this, this is what is there, and therefore I think this is what my result is. So you are able to communicate your thinking to somebody. That is intellectual knowledge. Certainty, which characterizes intuitive knowledge, is what Mendeleev had. He knew his periodic table is correct. He put those question marks because he knew it was correct. So he said, yes, it will be found. Some element would be found. Intuition does not oppose intellect, but rather lies beyond it. This is a very important sentence. Intuition does not oppose intellect. These are not two things against each other. In other words, intuitive knowledge, although it does not contradict the necessity of reason, questions the sufficiency of reason. You have to develop a high degree of perfection in intellectual knowledge before you can dare to use intuitive knowledge. Otherwise, intuitive knowledge just becomes some shabby guesswork. And Mendeleev was not doing guesswork. Today, you can predict a crystal structure through intuitive knowledge. It is not guessing. You're not guessing the result. You can predict the behavior of complex systems with intuitive knowledge. You can predict monsoons with intuitive knowledge. You need to have done a tremendous amount of reading in intellectual knowledge. For example, he wrote that bestseller book in organic chemistry, which was all about intellectual knowledge, before he was able to jump into this higher level of intuitive knowledge. Does not contradict the necessity of reason, but questions the sufficiency of reason. Here is another very important sentence. Intuition is not illogical, but super logical. It is above logic. It is not against logic. And finally, in summary, because you're doing a synthesis here, both intellect and intuition must be synergized in the quest for the nature of ultimate reality. It is not just the periodic table or the monsoon or biological system. It is for the ultimate reality itself. To question why we are, who we are, where we are, you have to use both intellect and intuition. This is what this gentleman was saying in this book, Idealist View of Life. And it communicates pretty well. I think many of our big results in science, DNA, for example, was an example of intuitive knowledge, the double helix. Kekule's discovery of the benzene ring, once again, intuitive knowledge. So great problems, big problems in science have been solved with intuitive knowledge. Now we come to the civilizational divide. Now the picture I showed you right in the beginning, right here, friends, is Königsberg, the hometown of Kant. We all know where Kashi is. It's somewhere right here. So there are two ways of thinking. This is Eurasia. This is the big Eurasian plain where human beings have been roaming around for thousands and thousands of years. All these places, the oldest part of the world, civilized world. And you see somewhere this black line which I have drawn is one of the biggest fault lines in the human race today. This is Königsberg. This is where Mendeleev lived, called Petersburg. And of course, he came from somewhere in Siberia, which is deep within Eurasia. So these two portions of Eurasia, which are divided by this black line, represent two different ways of thinking. Your Königsberg way of thinking and the Kashi way of thinking. Here the kings come and go. Here the super king stays forever. This is characterized by intellectual knowledge. This whole thing is characterized by intuitive knowledge. Neither may be better or neither may be worse, but both are equally relevant. And as Radhakrishnan says in that last sentence, both are actually needed to be synergized. He is using the word synergy to obtain answers to the ultimate reality of life itself, not just complex scientific problems. If you notice, even the geopolitical history of the world in the last 1,000 years, some of the bloodiest conflicts in human history have started in this region. This particular thing is a major fault line. When Huntington talks about the clash of civilizations and says it's all about the Western world versus Islam, I don't think he's correct. This is the biggest conflict of civilizations. This is one type of civilization. This is another type of civilization. It is no coincidence that World War I started here, World War II started here, the Cold War was here. Today, the Ukraine thing is here. Everything is, whenever the two utterly different civilizations start clashing with each other, that's when you're going to see conflict and bloodshed. And this is what is happening today. This is exactly what is happening. It repeats. This pattern goes on repeating. Those of us who live in this side must realize, scientists, social scientists, lay people, politicians, bureaucrats, everyone in India, we should realize, therefore, that the way in which we think is utterly different from the way in which people in this side think. There is no doubt about this. And, well, I'm just showing this for fun. This is a periodic table that I personally picked up when I went to Siberia many years ago. And since in Russian, I'm very fond of it, so I keep showing it now and then. But now coming to the second man with the beard, who I said I would explain. The second man with the beard, who looks like Mendeleev, is a fellow called Alexander Dugin. Now, this Dugin has given a political dimension today to the Eurasian civilizational divide. He is considered to be Putin's philosophical guru. And he argues, and Putin argues, that this whole so-called Western liberal democratic way of thinking is actually a crude form of capitalism, capitalist Western civilization, which is what the ancient Greeks called hubris. And he says that, as opposed to that, the Russian civilization, he calls it a civilization. He says that this Western model of thinking opposes heaven. For him, Russia is heaven, the ideal form in terms of space, time, being. The West would summarize the revolt of the earth against heaven. So the earth represented by the Western capitalist liberal thinking, which they call democratic. Let's not forget that the definition of democracy itself is different in different parts of the world. Dugin argues that democracy is something that is expressed by social groups, not by individuals. He's very clear about that. Dugin is a highly controversial person, by the way. And many people, especially from the liberal, so-called West, so-called democratic countries, oppose his thinking bitterly. But Putin himself now says, and he has said this way back even in 2007, he said, Russia's entire experiment with Westernization, starting with Peter the Great many centuries ago, he says the whole thing was a failure. He says because Russians are not like Westerners. If you were to ask me, Russia itself represents a civilization in transit between the pure Western civilization and, for example, the pure civilizational states like India and China. Don't forget, if you go back to the Asia map, China and India are the two major, big, powerful civilizations today. We are civilizational. We are not nation states. We don't think, behave, act, react like the Westerners. So we may have something called democracy, but it's different from democracy in the West. For example, Sandeep Balakrishna, the noted Indian thought leader today, he says that he doesn't mind democracy. He says what is wrong is Western democracy, because he says, according to him, Balakrishna, he says it is too Christianized. So he says it's Western democracy which is not suited to India. Dugin says something very, very similar. And Dugin also has developed this idea of empires. And according to these theories, which I think many seasoned commentators are now coming to some kind of agreement, is that there may be four empires in the world today: USA and the West, India, China, and Russia. Russia may be a civilizational state in certain bits like the West, but in most bits like the East. And so he says finally, the last sentence here, Dugin says values of democracy, human rights, individualism are considered by him not to be universal but uniquely Western. So today when the so-called liberals and wokes say that Ukraine wants to live in a democratic society, that is what Putin contests. He says Ukraine is a part of the soul of Mother Russia. It is a part of the Russian civilization. So he says all this talk about Ukraine wanting to live democratically in the free world is a lot of nonsense. So you see, this is the fundamental clash of civilizations on that Eurasian fault line. I showed you the chemistry example in the beginning, but you please see for more details things that I've written in my book, which Sangam Talks has very kindly agreed to have a future session, this time probably live, I think in person somewhere. So the whole idea of India itself being a civilizational state is something that I have described. I've also described Russia, and I've also described Europe a little bit in chapter 3 of his book. But you see, dear friends, I want you to look at this picture of the vast Eurasian plain. And somewhere on this plain, humankind underwent a total radically different way of thinking. So on one side of this plain was one way of thinking. On the other side was a completely different way of thinking. Mendeleev maybe combined the best of both worlds. He had all the advantages of the analytical Western reductionist way of thinking. And he had that rebellion, and he had that boldness and the daredevil character that intuitive thinking needs to be able to solve a very difficult problem in chemistry and be able to beat the famous German European scientists, so many of them living in places like Königsberg. They were not able to solve it with their methods. And so you can see, this is what Radhakrishnan meant. You need a synergy of both these things. You need the intellectual and the intuitive. And many people, chemists and other scientists, have declared that the periodic table of the chemical elements is one of the grandest achievements of human scientific endeavor. And all this came from this one guy, Dmitry Mendeleev. And his example also gives us so many other extensions. And so when you go away, please think about those two pictures. I do think, you look at these pictures again. And two things that are so very different. Obviously everything in these two cultures, in these two civilizations, will be utterly different. The challenge for us in India, I think, is to identify ourselves with what is going on in the right-hand picture and selectively use and take things from stuff that was developed in the left-hand side of the picture. Because that then will be a real synergy of intuition and intellect, which is what Radhakrishnan was asking for in his book. So with these words, I think, 50 minutes, Ojasvi, you said, so 50 minutes I have stopped. And if we have a little bit of time for questions, I will be most happy to take them.
Namaste, sir. Sir,
Namaste.
so I read it somewhere that Mendeleev was very much inspired from the categorization of Sanskrit alphabet, and he was a friend of Otto von Bottling, who means he was somewhat influenced by Panini Ashtadhyayi. So, can you throw some light on that?
So he was certainly influenced by that. You are quite right. And even the structure of the Sanskrit alphabet is a little bit like the rows and columns of the periodic table. And it will happen, you see, Prasoon, anytime when you have two completely orthogonal ways of characterizing the final property of something. Like the if you take the periodic table, do you have a science background, by the way?
Yes, sir. I'm from chemistry background. Actually, we met, sir, when you were in IT Kharagpur.
We met. Okay. Now look, if you take the periodic table, apologize to the non-scientific people in the audience. The rows essentially represent the size of the atoms, whereas the columns represent the properties. So the size and the property are actually not related to each other, but between the two of them, you will get a matrix. Now, if you take a language, if you take kacha tata pa, kakka gaga na chacha jajana. So the horizontal lines, kakka gaga na, they represent different types of movements of the palate and the tongue. And kacha tata pa represents differences in the columns. They represent movements of a different part of the mouth. So when you have the matrix of both these things, you will get the full alphabet. So not a surprise. Pandini also. If you take the Katapayadi scheme of which the Carnatic Melakatta ragas are organized, for those of you who are familiar with Carnatic music, it's the same principle again. There is one set of properties in a horizontal line. There is another set of properties in the vertical lines. So between the two of them, you have a matrix. So any property then can be explained. So it is quite what you have said is quite correct, and this I believe is how you can explain it quite easily.
So even though I don't come from a chemistry background, I wanted to know about as to what I know about Mendeleev through high school learning is that he was one of the first people to use atomic instead of atomic masses. He used I believe atomic numbers to classify the elements. So how did that facilitate the intuitive learning you're talking about?
No, it doesn't, because there is a slight inaccuracy in what you said. Only atomic weights were known in Mendeleev's time. The atomic number concept came a little later with a chap called Moseley in England. And it was then known that the atomic number is the number that is really chemically significant, not atomic weight. And when you start taking atomic numbers, then some of those question marks like tellurium and iodine don't become question marks anymore, because the atomic number of iodine is more than the atomic number of tellurium, even though the atomic weight of tellurium is more than the atomic weight of iodine. So when he puts the question mark, Mendeleev was therefore right in reversing tellurium and iodine, because with the knowledge known to him then, atomic weight, it wouldn't have made any sense. And when the atomic number thing came, this happens very often in science, that sometimes it's waiting for a property that's going to be discovered in the future. But the genius of the person is to then realize that it's not the theory, his theory that was wrong, but something in that data was wrong. And this illustrates also a general problem, that when you start developing theories on the basis of wrong or incomplete experiments, you can often get a wrong theory. It teaches you in another way also.